In the previous video, we introduced a potential one form A, which was A0 dx0 plus A1 dx1 plus A2 dx2 plus A3 dx3, where A0 was minus phi over c. Phi is scalar potential, and these AI's are components of vector potential, and x0 is ct, and x1, x2, x3, these stand for xyz coordinates. Then we define field strength F as differential of A, and its components were given as minus E1 over C dx0 dx1 minus E2 over C dx0 dx2 minus E3 over C dx0 dx3 plus B1 dx2 dx3 plus B2 dx3 dx1 plus B3 dx1 dx2. So the components of F, we denoted them as F mu nu and expressed them as matrix. So 0th component is 0, 1st component is minus E1 over C, 2nd component is minus E2 over C, 3rd component is minus E3 over C, 1/0th component is E1 by C, 2/0 is E2 by C, 3/0 is E3 over C, 1/1 is 0, 1/2 is B3, 1/3 is minus B2, 3/1 is minus 3/1 is B2, 3/1 is B2. Sorry, this is not 3/1, this is 2/1. So 2/1 is minus B3, 2/2 is 0, and 2/3 is B1. Then 3/1 is B2, 3/2 is minus B1, and 3/3 is 0. So these are the components of field strength. Now we have 4 Maxwell's equations, and these equations are divergence of B equals 0, curl of E equals minus del B over del T, and divergence of E equals rho by epsilon naught, and of B equals mu naught J plus epsilon naught del E over del T. These are the four Maxwell's equations in free space. Now two of these equations, these ones, they result from the fact that B can be written as curl of A, since divergence of curl is 0. So this is an identity. And similarly, E can be expressed as minus gradient of phi and minus derivative of A. So both of these two equations are identities, and in terms of these differential forms, these two equations can be summarized as df equals 0. Since f is an exact form in the sense that f can be written as differential of A, and since d2 is by default equal to 0, this is a property of exterior derivative, d2 equals 0, so this is an identity. This is called Bianchi identity for electromagnetism. And df equal to 0, if we take the components of df and put them equal to 0, we get these two equations: divergence of B equals 0 and curl of B equals minus del B by del T. Now this df equal to 0, if we write it in terms of f mu nu, then this df equal to 0 can be written as del alpha f mu nu plus del nu f alpha mu plus del mu f nu alpha equals 0. Here we have taken all cyclic permutations of alpha mu nu, then nu alpha mu, then mu nu alpha. So all cyclic permutations of alpha mu nu, and then we put it equal to 0. Here del alpha is a short form for del 0, del 1, del 2, del 3, where del I simply means derivative with respect to xi, and del 0 means derivative with respect to x0. So this equation df equal to 0 in terms of components can be written like this. The other two equations, these two equations here, if we write it in terms of differential form f, then they can be written like this: Hodge star of f, then differential of this Hodge star f, and again we take Hodge star of this 3 form. So we get a 1 form and we put it equal to J, where J is for current, which is as 1 form it can be written as minus rho C dx0 plus J1 dx1 plus J2 dx2 plus J3 dx3. Now we will not go into definition of this Hodge star operator. However, this equation we can write it in terms of components of f, And if we write it in terms of components, then this equation can be written as del mu f mu nu, where this repeated index is summed over, equals minus mu naught j nu by 2. Here j nu stands for the components of this one form j, so it is equal to minus rho c j1 j2 j3, and this upper index del mu, this is equal to minus del 0 del 1 del 2 del 3. We raise index with respect to the metric which has signature minus 1 1 1 1. So del upper mu is minus del 0 del 1 del 2 del 3, and j nu is minus rho c j1 j2 j3. We get this equation, and this equation is equivalent to these two equations here. So summarizing in covariant form, we can write Maxwell's equations as del alpha f mu nu plus del nu f alpha mu plus del mu f nu alpha equals 0, and the second equation is del mu f mu nu equals minus mu naught by 2 j nu. These are the two equations, and they are equivalent to the 4 Maxwell's equations, which in vector form can be written like this. The first equation is equivalent to these two equations, and the second equation is equivalent to these two equations here. In order to see that they actually are equivalent to these two Maxwell's equations, we can, for example, let us take this first equation here and take alpha to be 0 and mu nu to be 1 and 2. So we get del 0 f12 plus del 2 f01 plus del 1 f20 equals 0. Now f12, we can see it from here. F12 is 1/2 b3. F1 then 2 b3, 1/2 b3. So we get 1/2 factor is common to all of these, so we can ignore it. We get del 0 b3 plus f01. F01 is minus e1 over c. So we get minus del 2 e1 over c, and f20 is e2 over c. plus del 1 E2 over C equals 0. Now if we look at this thing here, we see that this is in terms of curl of E, this is del 2 E1 minus del 1 E2. So this is negative of the third component of E. Del 2 E1 del 2 E1 minus del 1 E2. So we get del 0 B3 minus 1 over C curl of E third component equals 0. Now del 0 is del by del x 0, so this is del B3 by del x 0. Now x 0 is CT, so this is 1 by C del B3 by del T, and this is 1 by C curl of E third component. So this equation gives, this implies curl of E third component equals del B3 by del T. Hence we get third component of this equation, but we are getting a wrong sign here. Del E del 2 E1 del 2 E1, okay, del 1 E2 del 1 E2 so this is plus, actually plus third component of right. So this minus del 2 E1 del 1 E2 is third component of curl of E, so we will get a negative sign here, as we should get, because in Maxwell's equation here we have a negative sign. So similarly, if we, for example, take del, if we take alpha to be 0 and mu and nu to be 2 and 3, then f23 is 2 3 is b1, so we get first component of this equation, this Maxwell's equation. And if we take alpha to be 0 and mu and nu to be 1 and 3, then we get second component of this equation. So all three components of these in this equation can be obtained from this equation here. Similarly, if we take, for example, instead of taking one of the indices to be time x0, if we take all the indices alpha, mu and nu to be spatial indices in this equation, if we take alpha 1, mu and nu 2 and 3, then we get alpha 1 f23 plus alpha delta 1 f23 plus delta 3 f12 plus delta 2 f3 3 1 equals 0. Now 2 3 is b1, so we get delta 1 b1 plus 1 2 is b3, delta 3 b3 plus delta 2 f31 3 1 is b2, so this is b2. So this is divergence of b equals 0. Now so we have seen that both of these two equations, divergence of b equal to 0 and curl of E equals minus del b by del t, can be written in compact form or in covariant form as this equation here. Now if we take the second equation, if we take this equation here, this one, and for example take nu to be 0, then we get del mu f mu 0 equals minus mu 0 by 2 j0. Now del upper 0 is minus del lower 0, right? But f00 is 0, so this does not contribute. Del upper 1 is simply equal to del lower 1, and f10 plus del 2 f20 plus del 3 f30, and this is equal to minus mu 0. j0 is minus rho c, so we get plus rho c over 2. f10 20 and 30 are 1 by 2 c. f10 is e1 by 2 c, so we get divergence of f20 is e2 and f30 is e3, so we get divergence of e equals mu 0 rho c by 2. Now this 2 cancels with this 2 here, and we get divergence of E equals mu 0 rho c square, but c square can be written as mu naught epsilon naught. Mu naught cancels with mu naught, so we get rho by epsilon naught. So this first equation, divergence of E equals rho by epsilon naught, can be obtained by putting nu equal to 0 in this equation. On the other hand, if we put nu equal to 1, if we take nu equal to 1, then what do we get? We get del mu f mu 1 equals minus mu naught by 2 j1. Now del upper 0 is minus del lower 0, f01 plus del upper 1 is del lower 1, f11, but this is equal to 0, so this does not contribute. Del 2 f21 plus del 3 f31, and this is minus mu 0 by 2 j1. Now f01 is 1/2 we take it common because 1/2 is a common factor in all of these. So f01 is minus E1 by C, so we get del 0 E1 over C. F21, what is F21? 0, 1 is E1 over C. F21 1 to F21 is minus B3. F21 is minus B3, so we get minus del 2B3. And F31 is B2, so we get del 3B2 minus mu 0 by 2J1. 2 cancels with 2 here, and this thing here can be written in terms of curl of B I j k del 1 del 2 del 3 B1 B2 B3. So in terms of curl of B, this thing is del 2 B3 del 3 B2. This is negative of the first component, so we get del, this was E1, del 0 E1 over C minus curl of B first component del 2 B3 del 3 B2 equals minus mu naught J1. Now if we rearrange it, we get curl of B first component equals mu naught J1 plus del E1. Del 0 is del by del x 0, but if we write it in terms of time derivative, we get del t with a factor of 1 by c, so we get 1 by c square del E1 by del t. So this we can write, since 1 by c square is mu naught epsilon naught, we get, by taking mu naught common, we get J1 plus epsilon naught del E1 by del t. So we get the first component of this equation by taking mu equal to 1. If we take mu equal to 2 in this equation, then we get second component of this equation, and if we take mu equal to 3, then we get third component of this equation. So the Maxwell's equations, in summary, Maxwell's equations are equivalent to these two equations here. This is an identity which comes from df equals 0, and this equation in geometric form is equivalent to this one in terms of Hodge star.